Hey folks, how's it going? It's Mr. Murray coming to you with a little video to help get you started thinking about the worksheet for today. Because it's definitely not an easy worksheet, and if you're starting from a place where you're like, man, I don't even know what I'd get started with, it's not obvious. So I'm going to walk you through the idea behind how you're going to do 6 and 7, and my hope is that you'll be able to use this to help you do numbers 8 and 9. Alright, my cat is also here with some stuff to say as well, apparently. Alright, so basically, the main difference here is that what I've gone ahead and done is I've added something off to the right. And what that's going to do is that is going to cause a shift in the graph. It's not going to be the same as, for example, if I just had straight up a third to the x, or if I had, for example, just straight up, right? It's not going to quite be the same as that. So as the worksheet suggests, the key here is that you do want to go ahead and make a table. Okay, and in your table, you're going to want to plug in, let's plug in 0, 1, 2, 3. Okay, let's see what happens. So I plug in 0, and we're going to follow PEMDAS. So PEMDAS says first exponents, right? Remember PEMDAS, PEMDAS. So when I plug in 0, first exponents, a third to the 0 is 1, then subtraction, 1 minus 1 is 0. Okay, then a third to the 1, putting 1, a third to the 1, exponents first, a third to the 1 is a third, because anything to the power of 1 is itself. 1/3 minus 1 is negative 2/3. Okay, 2. So if I was to do 2, right? A third squared is a ninth. 1/9 minus 1 is negative 8/9. It's like 1/9 minus 9/9. So what you can see is what you end up getting here is negative 26th, 27th. So see how you're getting really, really close to negative 1, but because the top and the bottom are not equal, right, you never actually get to negative 1. All right, now I'm going to plug in negative 1, negative 2, and negative 3. So remember, as always, you're going to do your exponents first. So a third to the negative 1. So remember, first you do the reciprocal, and then you make the exponent positive. So that's 3 to the 1, which is 3, and 3 minus 1 is 2. So negative 1, 2. All right, now I plug in negative 2. That gets me 3 squared, which is 9. 9 minus 1 is 8. And then negative 3 is going to end up being 26, and unfortunately that's not going to fit. So it's going to take off pretty rapidly at this point. All right. And there we go. All right. So hopefully you're able to get this one. And so the idea is it's just a little bit different than a straight up a third. And if you want to know what that looks like, I recommend you check out some like the examples, because I believe a third might have come up in a do now activity we did recently. Okay, so this is like exactly like a third to the x, except it's been moved down by 1, and that negative 1 tells you that's happened. Okay, so then real quick, 3 to the x plus 1, we do the same thing. X and f of x, 0, 1, 2, 3. 3 to the 0, right? So PEMDAS. So first exponents, 3 to the 0 is 1. 1 plus 1 is 2. 3 to the 1 is 3. 3 plus 1 is 4. Okay, 3 to the 2 is 9. 9 plus 1 is 10. 3 to the 3 is 27, plus 1 is 28. So that's basically all there. Okay, 3 to the negative 1. That's equal to 1/3 to the positive 1. And we should be adding, I apologize. Yeah, no, that's right. Adding 1. Okay, any case. So that would be 1 1/3 because I'm adding 1. Okay, then 2 is going to be 1 1/9. 3 is going to be 1 20 and 1/27. So see, basically, because the number you're adding is never going to become 0, and this is just a really rough sketch. Let me take another shot at that. So because the number you're adding, that fraction, is never going to be 0, you're always going to be just slightly higher than positive 1. Okay, so this is the idea. The graphs that we're going to do today, and these graphs you're going to see here, are going to be perfectly set up to fit the graph you need. So what we're going to do is we're going to use this idea of PEMDAS. We're just going to now mix in that additional component of subtracting or adding at the very end. But just remember, exponents and then the subtraction. Please make sure at the end you answer the question, what is actually happening to the graph?